Here we are again, looking at quadratic functions this time. We looked at linear yesterday, and we saw that that was stuff we did in Math 9. We're about to move on into the stuff that we've already done in Math 10, so this is more of a review. You can see we're doing quadratic functions, dealing with the same standard we dealt with a few months ago. We're going to be able to graph quadratic functions symbolically and show key features of the graph. Now, as we know, this is what a quadratic function looks like. We have a parabola. It's a U-shaped version of the parabola, and we can see that it does, in fact, have a minimum down there. Now, if this were an upside-down U-shape, we'd have a maximum. We can always tell by the sign of the squared variable. In this case, the x squared is positive, which means that this is going to have a minimum value. That's all old stuff, and again, this is all review for this chapter. So we can see here that the basic idea of this entire foldable is to come up with ways to have domain, have range, and set up our XY chart. As we can see in this particular example, we have our x values given to us. All we need to simply do is plug in each of those x values and write it in our y chart. So we take and plug in -2 into x, like so. If we compute this, we end up getting 0. Again, we take and plug in -1, subtract 4, and we end up getting -3. If we were to plug in 0, we end up getting -4. Now, because of the way this problem is set up, we know that that is the vertex. Because remember, we always want the vertex to be in the center. Meaning, this is going to be a symmetric XY chart. This is automatically -3, and that's at 0. Like we did a few chapters ago, we know that this is symmetrical because of the ways parabolas act in a graph. So go over to our graph, and we can go to the vertex first. 0, -4, -1, -3, and +1, -3, at 2, 0, and at -2, 0. We see that we have symmetry, and we can create our parabola like so. The new part about this entire chapter is adding in domain and range. We take a look. What x values can we plug into this function? Well, you could plug in a positive, a negative, a fraction, a radical, leading us to say that this is all real numbers for the domain. And in fact, for every quadratic equation we have, your domain will be all real numbers. We take a look at our range, though. This is where we have a small change. Is there a highest or lowest point in our graph? We take a look, and that is our lowest point. Meaning, our notation would read that our y values must be greater than or equal to -4. We cannot have a y value of -10. The lowest possible y value would be -4. Let's go to our final example, and for this example, we don't have our XY chart all set up. What we need to do now is remember how to find the vertex of a parabola. If we remember, the vertex is found by taking -b over 2a. we take a look at our equation of our parabola, and we see that a is the number in front of the x squared, b in front of the x, and c is the constant out by itself. So in this particular case, for the vertex, it's negative times b. Well, b in this case is negative 4. All over 2 times a. A in this case is negative 1. We do a little bit of simplification. So the top part, negative negative, turns into a positive 4. On the bottom, we have 2 times negative 1, so it's negative 2. We reduce this fraction, and we get negative 2. And that's where we're going to center the xy chart. And from here, we can just simply pick values, usually going up by 1s in both directions, to fill in the rest of our x values. Now, you may need a calculator for this part, so if you don't have one, I suggest grabbing one, and we need to simply input the values into our function. So as we plug in negative 4 into our equation, we end up getting that y is 2. Do the same thing for 0, and you see that that's also 2. Remember that we get symmetry with our parabola. If we plugged in negative 3, we'd end up getting 5. Same thing for the negative 1. And last but not least, we have our vertex, in which we end up getting 6. So again, that's all from simply plugging numbers in to the x spot in the equation. We go over to our graph at negative 2, positive 6. That's negative 3, positive 5, and negative 1, positive 5. Oops. Should be at 5, sorry. And at 0, 2, and negative 4, 2. To have our parabola that looks like this. Last but not least, we need to write our domain and range. Remember the trick. This is a quadratic, meaning that our domain is all real numbers. Always, for any quadratic, plug in any number. Our range, we take a look. It always starts off with y, because our y values deal with range. We take a look. Is this a minimum or maximum? That is a max, meaning that y needs to be less than or equal to the highest value, which is 6. We get this as our final answer. We have an xy chart, a graph, and our domain and range.